Good morning to everyone. Welcome to today's session. Today's topic is binary arithmetic, addition, subtraction, multiplication and division. Binary arithmetic. So arithmetic, it is nothing. It is having four different calculations as addition, subtraction, multiplication and division. By end of today's session, you will be master in addition and carry propagation, that is binary addition. Next one is subtraction via 2's complement, binary subtraction. Next it is binary multiplication. So the binary multiplication carried over by shift and add. The fourth one is a binary division. That is a long division method. You have to do bit by bit. Okay, the foundation for this, that is a positional weight. Okay, so I want to recollect you the module 18. So in module 18, you have learned the digital number representation and number system. In the digital number representation, I have told you the number systems are classified into two types. One is a non-positional number system additive and the positional number system weighted. So here the positional number system weighted to be comes into the picture. Means that every bit value depends only on its position and power of 2. So when will you get that power of 2? Kindly recollect, it is happening only in the binary representation. And next one, you have to do right to left representation, because what is the rightmost bit? Try to recollect. Yes, rightmost bit is the least significant bit and the leftmost bit is the most significant bit. Next here I have mentioned you four numbers, 8421. What is this 8421? It is a code, right? So in this 8421 code, where you studied this 8421 code? In the hex representation. In the 8421 code, 1. The position is 2 power 0. 2, the position is 2 power 1. 4, the position is 2 power 2. 8, the position is 2 power 3. So I have given the binary values here 1, 0, 1, 1. What is 1? On condition. 0, it is a off condition. See, on condition is green in color, off condition is black in color, right? Okay. So now I want to find what is the value for this 1, 0, 1, 1. So the position 8 occupied, the position 2 occupied as well as position 1 occupied. So 8 plus 2 plus 1. What is the value? 11, base 10. Remember what is this base 10? It is a radix, right? Means that this is a decimal number. The values lies between 0 to 9. This is a positional weight, which is a foundation for this binary arithmetic. Right. So 4 sections you have to learn. The first section is binary addition. Right. So how to do the binary addition? Binary addition must do column by column. Right. Remember a matrix, rows and columns. So how to do the binary addition? It is column by column. And whenever any carry is there, the carry will be overflowed. The overflow carry will be forwarded to the next highest value, right? I mean a next highest position you can consider, right? Okay. So we will see what are all the rules to do the addition operation, right? The 4 addition rules are, right? So before going into this, just recollect how to do the addition. It's a normal decimal addition also. So how to do? You need a 2 values, right? A as well as B. I mean added and augment. You need a 2 values. So that added and augment I meant it as A and B. While doing the addition, what is the result you will get? You will get the sum. Sometimes you will get the carry also, right? For example, if you are adding 1 plus 2, the result will be 3, right? If you are adding 2-digit number, whatever resultant you are getting, the resultant will be forwarded to the next representation. Yes or no? Yes. At that time, we used to call it as a carry. So, here the inputs are 2, A and B. So, binary you are using. So, how to write the binary? 2 power 2. Because 2 are inputs and your binary is 2. So, 2 power 2, 4 values. The 4 combinations are 0, 0, 0, 1, 1, 0 and 1, 1. Check here. While adding 0 plus 0, sum is 0 as well as carry is also 0. While adding 0 plus 1, sum is 1 and carry is 0. If it is 1, 0, again 1 plus 0, sum is 1 and carry is 0. If it is 1, 1, remember 1 plus 1, generally it is 2. In the top you check, I have written no digit for 2 exists in the binary because binary is a combination of zeros and ones. So 1 plus 1 rolls over into carry. So 1 plus 1, what is the resultant I got? 1, 0. In the 1, 0, the least significant bit is sum and the most significant bit is carry. So that's why I have written sum is 0 and carry is 1. This is the only one thing you have to remember while doing the addition operation. So 1 plus 1, sum is 0 and carry is 1. Based on this, we will check some problems, right? So the first worked example, 111 plus 101, right? Already I said column only you have to add. Consider A is equals to 111 and B is equals to 101. Consider one is added and another one it is a augment. A is a added, B is a augment. So what you have to do? You have to add bit by bit, column wise. See here, so 1 plus 1. In the principle I said 1 plus 1 is 1, 0. So sum is 0, carry is 1. In the next column, right? Sum is 1. A is having a 1 and carry is 1. So 1 plus 1, 1, 0. 1, 0 plus 0, 1, 0. So sum is 0 and carry is 1. In the third column, carry is 1 and addend is having 1 as well as augment is also having 1. So 1 plus 1, 1, 0. 1, 0 plus 1, 1, 1. So 1 will be written as a sum and one more 1 is written as a carry. So 1 plus 1, 0. Sum 0, carry 1. 1 plus 1 again. Sum 0, carry 1. 1 plus 1 plus 1. Sum 1 as well as carry is also 1. So what is the resultant now? 1, 1, 0, 0. Right? Okay. So what is this 1, 1, 1? This 1, 1, 1, it is actually 4 to 1 code. I hope you remember. The 4 to 1 code that is there in the octal representation. Right? 4 to 1. So 4 plus 2 plus 1, the value is 7. 1, 0, 1. 4 is 1 as well as 1 is 1. So 4 plus 1, it is 5. So what is 7 plus 5? 7 plus 5 is 12. So 12 is the value available there in your hexadecimal. Right? So in your hexadecimal, how you supposed to write? It is 8421 code. So 8 is having the weight 1 as well as 4 is also having the weight 1. So 8 plus 4, 12. Right? So 7 plus 5, 12. In a decimal, the same in the binary addition, you are getting that same value. See here, 1, 1, 1 plus 1, 0, 1 is 1, 1, 0, 0. So 7 plus 5 is equals to 12 in decimal, right? We will do it for 4 bits. What is a 4 bit? Good. Nibbles is a 4 bit, right? So I am taking 4 bit. 1011 plus 1101. Consider A is equals to 1011 and B is equals to 1101. A is added and B is augment. Okay, so I am doing the addition. Column by column you have to do. So the first column 1 plus 1. So what is 1 plus 1? It is 1 0, right? So means that 0 is sum, 1 is carry. In the second column, again 1 plus 1. What is 1 plus 1? 1 0. 1 0 plus 1, 1 0. Again, sum is 0 and carry is 1. So next check 1 plus 0. 1 plus 0 is 1. 1 plus 1 is again 1 0. So sum is 0 and carry is 1. In the last column, carry 1, addend is having 1 as well as augment is also having 1. So 1 plus 1, 1 0. 1 0 plus 1, 1 1. So sum is 0 and carry is 1. So what is the resultant you got? 1 1 0 0 0. See here, I want to recollect you one point, overflow. What is overflow? The extra bits available once the register completed. Here what is the register? 4-bit register. So the 4-bit register completed 1 0 0 0. The 1 is a overflow. So that's why we used to call it as a overflow carry, right? Again, what is 1011 in decimal? 8 plus 2 plus 1. So 8 plus 2, 10. 10 plus, see 8, 4, 2, 1, right? So what is that one? 8, 2, 1. So 8 to 10, 10 plus 1, 11, right? What is the next representation? 8, 4, 1. 8 plus 4, 12. 12 plus 1, 13. So what is 13 plus 11? It is 24. So we can check whether it is 24 or not. 2 power 0, 2 power 1, 2 power 2, 2 power 3. What is 2 power 3? 8. What is 2 power 4? 16. So 16 plus 8 is 24. 24 in decimal. This is the way how you have to perform the binary addition. One thing you have to remember is the 4 rules. That's it. The second section is binary subtraction. So binary subtraction, if you want to do the binary subtraction, you can follow 1's complement or 2's complement, okay? But you should not take that 2's complement subtraction. Instead of that, it is 2's complement addition, right? The thing is, there is no direct subtraction. So instead of direct subtraction, what we are doing? 2's complement addition. Because while taking the earlier module, I told we have used a single circuit, that is the adder circuit. That adder circuit will do both the operation addition and subtraction. There is no separate subtraction circuit, right? That's one. So what you have to do? Instead of doing the direct subtraction, you have to do the 2's complement addition. This is a point you have to remember here. Okay, right. So 2's complement method. Already you know what is 2's complement method. Okay. What is a 2's complement method? Whenever you want to do any subtraction, you need two values. One is a minuend and another one it is a subtrahend. Okay. So the subtrahend, the minuend is defined as A and the subtrahend is defined as B. The subtrahend should be converted as a 2's complement. Those 2's complement value should be added with the minuend A, the way you are getting the subtraction. Whatever you know in the earlier presentation also. By the next slide, I will tell you how to do that process, right? See here, A minus B. So A minus B represents that it is a direct subtraction. But we are not doing the direct subtraction. Instead of that, what we are doing? 2's complement addition. So A plus 2's complement of B. Why we are going in that way? Because we can use only one circuit, adder circuit, that can able to do both the operations. So hardware only needs an adder. So for this 2's complement, you have to follow 3 steps. The first step is flip every bit of B. What is B? Which is subtrahend. You have to convert every bit of B. Step 2, you have to add 1. Because what is your aim? You have to convert it into 2's complement. What is 2's complement? 1's complement plus 1. Step 3. You have to add the 2's complement to A. That's why I represented it as add result to A. Right? Right. So what is the step 1? 1's complement. Step 2, 2's complement. And step 3, addition of given A with the 2's complement of B. Right? Okay. So after doing this addition, there are two possibilities error. The first possibility is carry out is equals to 1. The second possibility is carry out is equals to 0. If carry out is equals to 1, blindly discard the carry and consider the answer is positive. If the carry out is equals to 0, it is actually the negative number. So if it is a negative number, you have to take the complement of the result. Okay. So carry out is equals to 1. Discard the carry. The answer is positive. Carry out is equals to 0. Answer is negative. And recomplement the result. Okay. Based on this, we'll do two problems. Right. One problem where carry out is equals to 1. One problem where carry out is equals to 0. Right. Okay. Listen this problem. Subtraction. 1101 minus 0100, right? 1101. What is this 1101 and 0100? Both are the 8421 code. So 8 plus 4, 12. 12 plus 1, 13. Minus again 0100, 8421 code. So it is 4. So here it is 8 plus 4, 12. 12 plus 1, 13. 13 minus 4. What is 13 minus 4? It is 9, right? So what is the result you should get? 9 should be the result you should get. We will see whether it is coming or not. What is the first step? 1's complement of the subtrahend. Which is a subtrahend here? 0100. I defined it by the letter B. What is minuend? 1101. I defined it by the letter A. So A is equals to 1101. B is equals to 0100. The first step is how to take the 1's complement of B. What is 1's complement? Flip the bit or invert the bit. 0 to be converted to 1 and 1 to be converted to 0. So step 1, I am flipping. So 0 converted to 1 and 1 converted to 0. In that way, the result is 1011. Step 2. What is step 2? Step 1, 1's complement should be added with 1 at the LSB. Right? Step 2, add 1 to 1's complement. The resultant is 2's complement. So what is your 1's complement? 1011. Check the first row, 1011. What you have to do? You have to add 1. Where you have to add? You have to add at your LSB. So LSB, I have given the value of 1. You can think why these 3 zeros are. Again, it is a underflow, right? It is not an overflow, it is an underflow. Underflow represents that, see, it is actually the nibble. What is meant by nibble? Right, 4 bits are the nibble, right? So this register is having 4 bits. So this is actually termed as a nibble, right? Okay, so in the nibble, only one position is having the value, other position don't have any value. So that's why I just appended or padding with the zeros, right? Next you have to do the addition. So what is 1 plus 1? 1, 0. I mean sum is 0 and carry is 1. In the second column, again 1 plus 1. What is 1 plus 1? 1, 0. 1, 0 plus 0, 1, 0. So the sum is 0 and carry is 1. In the third column, 1 plus 0, 1. 1 plus 0, 1. So 1 I have written at the resultant part. In the fourth column, 1 plus 0, the resultant is 1. So what is the 2's complement of B? It is 1100, right? So second step is over. What is the third step? This 2's complement should be added with the A. Step 3, add A plus 2's complement. So what is your A? 1101. Check there. The first row is 1101. What is the second row? 2's complement of B. What is 2's complement of B? 1101, 1101, right? While adding, what is the result you got? 1 plus 0 is equals to 1. 0 plus 0 is 0. 1 plus 1, 1, 0. Sum is 0, carry is 1. So 1 plus 1, 1, 0. 1, 0 plus 1, 1, 1. Sum is 0, carry is 1. Remember, the first output block, what you checked? Carry out is equals to 1. Then you have to discard the carry. So, means that no need to consider that carry, right? You have to consider only the remaining element. At the same time, this value is a positive value. So, carry generated. So, discard the carry, it is a positive value. What is the result? 1001. In 8421 code, what is 1001? It is 9. So, what is 13 minus 4? It is 9. So, this is a positive result subtraction. Next, we will see how to do the negative result. Okay. In the negative result, I have taken the value 0100 minus 1010. What is 0100? 4. What is 1010? 10. What is 4 minus 10? It is minus 6. So it is a negative result. Right? We will see whether we are getting that same result there in your binary representation also. As usual, write A is equals to 0100 and B is equals to 1010. In the step 1, do the ones complement of B. What is B? 1010. So step 1, you have to take the ones complement. So 1010 will become 0101. What is your step 2? With the ones complement, you have to add 1. So 1 should be added at the LSB and the remaining places and all will be appended with zeros. So step 2, add 1 to 1's complement. The resultant is 2's complement. What is the 1's complement? 0101. What is the LSB? Addition 1. So the remaining places append with zeros. So 1 plus 1, 1, 0. I mean sum is 0, carry is 1. 1 plus 0, 1. 1 plus 0, 1. 1 plus 0, 1. Which is available in the third column. 0 plus 0, it is 0. So what is the resultant you got? 2's complement of B, 0100. Right? What is your third step? The 2's complement of B should be added with A. Add A plus 2's complement. What is a A value? 0100. What is a 2's complement? 0110. You have to add. First column 0 plus 0, 0. Second column 0 plus 1, 1. Third column 1 plus 1, 1, 0. Sum is 0, carry is 1. Fourth column 1 plus 0. 1 is a carry. 1 plus 0, 1. 1 plus 0, 1. See here, there is no carry out. So no carry out in the sense carry out is equals to 0. If carry out is equals to 0, what it means? It is a negative result. But how to do that negative result? By taking the ones complement of the actual result. So what is the ones complement of actual result? 1 will become 0. So the MSB is 0. The next bit 0 becomes 1. The third bit towards the LSB, the third bit 1 becomes 0 and LSB 0 becomes 1. So what is the value? 0, 1, 1, 0, right? So 0, 1, 1, 0, right? Okay. So if you are taking in that way, right? So what is the result you will get? 1 will become 0, 0 will become 1, 1 will become 0, 0 will become 1, right? Okay. But what kind of subtraction you are doing? 2's complement addition based subtraction. So again what you have to do? The least significant bit should be added with 1. In that way, what is the result you will get? 0, 1, 1, 0, right? But it is a negative number. So that's why I have given the negative sign there. So earlier itself, what is the result we got? 4 minus 10 is equals to minus 6. After doing the binary subtraction also, what is the result we got? 0, 1, 1, 0. Okay. See, here also you have to take a 2's complement. Please don't forget. Okay. So 0, 1, 0, 1 you will get. So 0, 1, 0, 1. Right? So you have to add 1 with the LSB. So 1 plus 1, 0, 1. So 0, 1, 0, 1 is the result. Okay? Right. So the short point you have to remember is carry out is equals to 1. It is a positive value. So you have to write only the actual value and discard the carry. If it is a carry out to 0, means that it is a negative number. You have to take a 2's complement of the result and you need to add the negative sign there. Okay, that is your binary subtraction. Right? Okay. Next section is the binary multiplication. Remember, there is no need to remember the multiplication table. Okay, no multiplication table is needed. Only two operations we are doing. Shifting operation as well as the AND operation. So shift in the sense from the LSB towards MSB, you have to shift 1 places for each and every partial product. I will tell you how you have to do that part. Okay. I have taken the example as 1011 multiplied by 101. Okay. So here, what you have to do? You have to take the partial product, right? So the partial product, shift 1 place left, then everything is summed. Take down the first value 1011 multiplied by 101. So check your first row. What is there in your first row? 1011. The 1011 should be multiplied by 1. 1 into 1, 1. 1 into 1, 1. 0 into 1, 0. 1 into 1, 1. So in the first row, in the resultant first row, I have written it as 1011. This 1011 is a partial product. This partial product happened because of this 1011 multiplied by 1. What is the second bit there? 0. So the first row 1011 should be multiplied by 0. So if anything multiplied by 0, the value is 0 only. But where you have to start? You have to start at the second one. Not in the LSB, in the next bit. Not in 2 power 0 instead of 2 power 1. So in the 2 power 1, I have to start. That's why I said shift. So 0, 0, 0, 0, right? The LSB is also carried the 0, but that 0, I made it as a appended, padded 0, not the actual 0, right? So what is the third bit in your second column? Second row, 1. So third bit in your second row is 1. So again this 1 should be multiplied by the first row. So 1011 into 1. Again you will get the 1011. Earlier you started the bit at 2 power 1. Now you have to start at 2 power 2. Right? 2 power 0, 2 power 1. Now you have to start at 2 power 2. Because you have to make one shift. So 1 into 1, 1. 1 into 1, 1. 0 into 1, 0. 1 into 1, 1. Right? Now you have to add. Right? The first value is 1011. The second value is 0000 appended with 0. The third value is 1011 appended with 2 zeros. Now you have to add. 1 plus 0, 1. 1 plus 0, 1. 1 plus 0, 1. 1 plus 0, 1. 0 plus 0, 0. 0 plus 1, 1. 1 plus 0, 1. 1 plus 1, 1, 0. So sum, I have written it as 0. Carry, I am taking it to the next bit. So 1 plus 0, 1. 1 plus 0, 1. The last bit again it is 1. Okay. So what is the resultant I got? 1, 1, 0, 1, 1, 1. Right? Okay. So what is 1, 0, 1, 1? In the 8421 code, 8 plus 2 plus 1. 8 plus 2, 10. 10 plus 1, 11. Please check the result. What I have written in green color. What is 101? It is actually the 421 code because it is having only 3 bits, right? 2 power 3. So 4 plus 1, 5. What is 11 into 5? 55. What is the result you got? 011 0, 1, 1, 1. Again check 2 power 0, 1, 2 power 1, 2, 2 power 2, 4. So 4 plus 2 plus 1. 4 plus 2, 6, 6 plus 1, 7. So 2 power 3, there is no value. 2 power 4, 16. 2 power 5, 32. So 32 plus 16 plus, check here, there is no 8, 4 to 1. So the result it is 55 in decimal. This is the way you have to do the multiplication. Check the resultant first row 1011, partial product 1, all zeros. Partial product 2, 1011 with 2 zeros appended, partial product 3. So each partial product should be shift one place left. Okay. After summing, this is the result you got. This is a multiplication, how you have to do. The last section is a binary division, right? The binary division, you have to work out three things. You have to compare, you have to subtract, you have to bring down. But one bit at a time. We will see how that is happening. So what is the division example I have given? 1, 1, 0, 1, 1, 1, 0 divided by 1, 1, 0. So this is the, see, divisor as well as dividend, right? You have to use a divisor and you have to use a dividend. So you will get the quotient as well as you will get the remainder. Okay. Cubic. Please check this table. In the table, I have given step. Next one, I have given the window. The third one, comparison. Fourth one, qubit. Qubit is nothing which is a quotient bit. And the last one, it is a remainder. Okay. So each row brings down the next bit and tests again the divisor. We will see. Step 1. In the step 1, kindly take that MSB. In the divisor MSB, right? Divisor MSB as well as dividend MSB, right? Okay. So what is your MSB? 1. So 1 should be divided by 110. What is 110? What is that 110? It is 4 to 1 code. What is that 4 to 1 code? 4 plus 2, 6. Whether 1 divided by 6, you have to compare. 1 divided by 6, absolutely no. So qubit is 0, the remainder is 1. Step 2. Take that next bit. Okay, I will give you in that way. 2 power 0, the value is 0. Face value is 0. 2 power 1, the face value is 1. 2 power 2, the face value is 1. 2 power 3, face value is 0. 2 power 4, the face value is 1. So now take the 2 power 4. Earlier you brought 1. It was not divided by 6. So the remainder is 1. Now you have to take 11. 1, 1. So what is 1, 1? 1, 1 means it is 3. Whether it is divided by 6? No. While comparing, it is also not divided by 6. So quotient is 0. What is your remainder? Remainder is 3. Not a 0. Remainder is 3. In the step 3, you have to take that 0 also. Now what is your value? 1, 1, 0. Whether 1, 1, 0 divided by 1, 1, 0? Yes, it is greater than or equals to. So what is your quotient now? Quotient is 1. Here there is no remainder. Remainder is 0. In the fourth step, you have 1, 1, 0. Now you have to bring that 1 also. So what will be there in your fourth step? 1. Because 1, 1, 0 already divided, you got the quotient and the remainder is 0. Now check 1. Whether 1 divided by 1, 1, 0? While comparing? No. So at that time, what is your quotient? 0. What is your remainder? 1. In the next step, again what you have to bring? You have to bring 1. Now the value is 1, 1. 1, 1 means it is 2 plus 1, 3. Right? Whether 3 divided by 1, 1, 0, 6? No. So again, the quotient is 0 and remainder is 1. In the next step, bring that 0 also. I mean in the step step 6, bring that 0 also. Now what is your value? 110. Whether 110 divided by 110? Yes, it is greater than or equals to. So the quotient is 1 and remainder is 0. Right? Now check what is your quotient? 1001. What is your remainder? 0. Again check this. What are the values there? 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5. What is 2 power 5? 32. What is 2 power 4? 16. 32 plus 16, that is 48. Right? Next, 4. 4 plus 2. So what is 4 plus 2? 6. So 48 plus 6, 54. What is your divisor? 110. So 110 in the sense 4 plus 2, 6. So 54 divided by 6 is equals to 9. The remainder is 0. What is the quotient you got? 1001. What is 1001? 8 plus 1, 9. Okay. So this is the way how you have to do the multiplication, division, subtraction as well as addition. This is a quick reference and a recap, right? Everything of today's part. Addition. In the addition, you have to follow the addition rules. What is the addition rules? 0 plus 0, 0, 0 plus 1, 1, 1 plus 0, 1, 1 plus 1, 1, 0. How to do the subtraction? First, you have to do the flips, inversion of the B. After that, you have to add 1 to the inverted value. 1's complement plus 1 becomes the 2's complement. Then add it to A. If carry is there, discard the carry, consider the remaining values. If there is no carry, you have to consider it as a negative number. At the same time, you have to do the 2's complement of the result. If it is a multiplication, 0 into 0, 0, 0 into 1, 0, 1 into 0, 0 and 1 into 1, 1. If it is a division, you have to do first step as a compare window. One bit, each and every bit should be compared with the divisor. Okay, divisor and dividend should be compared. Okay, so after the comparison window, if the divisor is greater than or equals to, consider it as a 1. If the divisor is less than, consider it as a 0. Bring down all the value, repeat one after another. Okay. So addition, rules 4, subtraction, it is 3 plus 2, 5, multiplication 4, as well as division is also 4. Right? Okay. So by the end of this session, I have taught you how to do the binary addition, how to do the binary subtraction, how to do the binary multiplication as well as the binary division.